Hello everyone. In this new video series, I will be taking up questions which were recently asked in GATE 2021 exam, mathematics. And to begin with, I'm going to take up questions asked from the section linear programming problem. So without any delay, let's get started. So I'm sharing the screen with you. There I have already written a question from GATE 2021. It was question number 55. So let's first try to understand the statement of this question, and then we will see how to solve this kind of questions. So you are given in the statement optimal solution. As you can see, you are given x tilde. So this be an optimal solution of the following linear programming problem. So you are given LPP with three variables and three constraints. Three variables are having the non-negativity restrictions, and there are some arbitrary unknowns a and b. And then it says if y hat is PQR is an optimal solution of the dual of P, then P plus Q plus R is equal to, and you have to round off to two decimal places. So basically you need to find this and then round off to two decimal places. So let's see how to proceed in this case. Since it is asking for the solution of a dual, so we need to write the dual of this linear programming problem first, and then we will see the connection between the optimal solution of the primal and the optimal problem solution of the dual. Because there is a theorem known as complementary slackness theorem, which tells us that there is a relationship, and given one solution, like if you are given optimal solution of primal problem, we can use that information and the information coming from the primal problem to find out what is the optimal solution of the dual problem. So let's see how to do that. Okay, so firstly, very quickly, let's write the dual of this problem. So in this video, I am not focusing on explaining to you how to write the dual. So that I will explain sometime else, or you can find that in my other videos. But right now, I'm directly writing the dual. So it has three constraints. So dual will have three variables. So this is going to be 10y1, 3y2, 11y3, and the constraints are going to be 2y1 plus y2 plus 2y3, 4y1 minus y2 plus 3y3, ay1 plus by2 plus 5y3. The right hand side of the constraints is the coefficients coming from the objective function of the primal, so that is 4, 1, minus 3, and these three variables are going to have some restrictions. So since in primal all the constraints are less than equal to, and that's a maximization problem, so the constraints, so the variables of the dual are going to be non-negative, and similarly the variables are non-negative here, so this will give me the constraints should be greater than equals to. So I have written the dual. Now I have been given that this PQR is an optimal solution of the dual of P, and I need to find this. So basically I need to find the values of P, Q and R, only then I can compute this sum. So here I will be using complementary slackness theorem. So the complementary slackness theorem is having a relatively bigger statement, but in this question, I will be just showing you the one which we are going to use. So according to complementary slackness theorem, if the variables in the optimal solution of primal, that means like if you look at the solution which is given to you, 11 by 3, 2 by 3, 0. Since these are satisfied as non-zero, means these two variables, x1 is non-zero and x2 is non-zero, where in the optimal solution of primal, in that case the first and second, because it's coming from the index x1 and x2, so the first and second, so the first and second constraints of dual are going to have no slack, means the optimal solution of the dual will be satisfying the first and second constraints as equality constraints. So that means if these constraints are greater than equals to, they will be exactly satisfied as an equation. So the surplus variables coming over here and here will be zero. That is what it means. So let's see how we translate this information to our usage. Now, since we are given that PQR is optimal solution of dual, it implies this PQR is also a feasible solution of dual. So if it is a feasible solution, so that means it is going to satisfy the constraints. And I just told you that we can see that the first two constraints are going to be satisfied as an equation. So we will have directly substituted PQR for y1, y2, y3. So this will be 2p plus q plus 2r is equal to 4, 4p minus q plus 3r, right? The second constraint is equal to 1. And so we have this information. And also, if you look at that, the third variable is going to be 0. R is going to be 0 because if you look at the third constraint here, if you put this directly into this constraint, so you will get 2 into 11 by 3 plus 3 into 2 by 3 plus 5 times 0 is less than equals to 11. So obviously this will be satisfied, but let's just compute the left hand side. So 22 plus 6, 28 by 3 is less than equals to 11, and this is not exactly equals to 11. So that means the slack here is non-zero. So if slack here is non-zero, so the corresponding third variable is going to be 0 in the dual. So you see the connection. The variables being 0 in the primal are deciding the slacks being non-zero in the dual, and vice versa, right? So since this slack is non-zero, the third constraint, so that means the third variable here is 0. So the third variable 0 means R is equal to 0 in the optimal solution. So you see, now we got this information. It's very easy for us to find the value of P and Q. So you put R is equal to 0, you will get two equations. 2p plus q is R, 4p minus q is 1. You just add these, so you will be getting, sorry, let me see the equation. What was this? Yes, this is right. So when you add this one, so you will be getting 6p is equal to 5. So p is equal to 5 by 6, and you substitute in any one of them. So 2 into 5 by 6 plus q is 4. So q is 4 minus 10 by 6. So that is 14 by 6, which is 7 by 3. So you got the value of p is 5 by 6. You got the value of q is 7 by 3, and r is 0. Now all of you can compute p plus q plus r. So this is 5 by 6 plus 7 by 3 plus 0. So this will give me 14 by 6 basically. Sorry, 14 plus 5, 19 by 6. Yeah, so this will be 3.1 something, right? So it will be 3.16. Yeah, so that is the answer. So you can round off to two decimal places. It now it's already rounded to two decimal places. So that's about it. That's how you solve these kind of questions. So you can have a look at the complementary slackness condition. I can tell you once again what I did. So if in the primal optimal solution, one of the variable is non-zero, so that means the constraint corresponding to that variable in the dual will be satisfied as an equation. So since first and second variable were non-zero, so the first and second constraints of dual were already equations. That is why I directly wrote them as equation. And if any of the constraints in the primal is being satisfied as strict inequality, means it's not satisfied as an equation, means there is some non-zero slack in that particular constraint, that corresponding variable in the dual is going to be 0. So one of them have to be non-zero, the other one is going to be 0. So if the third constraint, the slack, was non-zero present, that means the third variable in the dual has to be 0. So we used these conditions and we got our answer. So that's all about this question. I'll bring up more questions from LPP GATE 2021. Thank you for watching.